Welcome back. This is day 2 of Unit 3, Coordinate Geometry and Systems of Linear Equations and Inequalities. We're going to continue with solving systems by elimination. This is part 2. Turn in your workbooks to page 116. Complete this warm-up. Take 5 minutes. We're going to be multiplying equations by a factor. So first you need to know what a factor is. A factor is something that you multiply to another number. Let's take a look at 6 as an example. 6 has several factors, several numbers that you can multiply together to get 6. So to find those factors, we're going to divide 6 into 2 numbers that will multiply to give me 6. So that would be something like 1 times 6 or 2 times 3. Can you think of any other numbers that multiply to give you 6? I'm thinking of whole numbers. So right now that's all I can find that multiply together to give me 6. Now if we have a factor that we want to multiply to an equation, we're going to take that factor and multiply it through. Every term is going to be multiplied through by that factor. This is not in the book. We are starting on 116. So if you'll turn to page 121 and you'll write this down in that section, that debrief section at the end of this unit. It's asking, what is the solution to this equation? If we multiply both sides of the equation by a factor, I'm just going to pick the factor 4. What equation would we have? So the way that we do that is we take that factor 4 and we multiply every term by 4. So 4 times x, what would that be? Write it down in your workbook on page 121. All right, but we can't stop there. We have to multiply the 4 to the 5. What's 4 times 5? 4 times 5 is 20. And then lastly, we've got to go to the right side of the equation and multiply 4 times 11. 4 times 11 is 44. So we have an equation, 4x plus 20 equals 44, that's equivalent to the equation x plus 5 equals 11. If we solve each of these equations, we'll get the same solution. So what is the solution to this new equation? Okay, let's go ahead and solve it. Subtract 20 from both sides. Subtract 20 from both sides. Draw that line. Keep your sides separate. You can draw a straight line, or don't forget to write your equal sign, however you'd like to do that. On the left hand side, 20 minus 20 is 0. Bring down the 4x. This line is indicating equal to separate the right hand side of the equation from the left hand side. 44 minus 20 is 4 minus 0 is 4. 4 minus 2 is 2. 44 is bigger than 20, so this is going to be positive. And then finally solve by dividing both sides by 4. 4 over 4 is 1. This is 1x on the left equals 24 divided by 4 is 6. Now let's go back to the original equation. Subtract 5 from both sides. That's the only step that we have to take in this equation, but we're still going to get the answer, the solution x equal 6. Okay, so those are equivalent. What if we multiply both sides by 100? I would get 100x plus 5 times 100. Yes, 5 times 100 is 500. And then 100 times 11 is 1100. And then solving that equation, subtract 500 from both sides. All right, 500 minus 500 is 0, so that crosses out. Bring down the 100x, bring down your equal sign. 1100 minus 500 is 600, and then divide both sides by 100. Again, write this down in your workbook on page 121 and show your steps. X is equal to 6. So the point is, we can write equivalent equations by taking a factor and multiplying every term by that factor to create equivalent equations. The solution to each of these equations is still 6. All right, consider these two equations in this system. So we have equation A, 4x plus y equals 1, and equation B, x plus 2y equals 9. What could we multiply the top equation by to create an opposite so that something cancels when we combine? So we've got the system written down here. So look here where we have equation A1. We have some room to show our work. So I've copied these two equations down. What could we multiply that top equation by every term to get a matching coefficient somewhere? So you've got a couple of choices. Think about what you would use and then write it down in your book. This is on page 116. All right, pick something, and then on question 2A, think of something that you would multiply this top equation by. I'm going to multiply the top equation by -2 so that I have a -2 here. That's my goal. All right, but I've got to multiply that -2 by the 4 and the -2 by the 1. In other words, distribute it to every term in that equation, both on the right and on the left. Okay, so 2 times 4 is going to be 8x. I'm going to write it underneath, but it's going to be a -8x because we're distributing a -2. -2 times 1y is -2y. Bring down the equal sign, and then -2 times 1 is -2. All right, so these are the two equations that we're going to add together, and we'll see that the y is eliminated. 2, oops, I forgot to go slowly. That's a -2y, and then that's a -2. All right, 2 take away 2 is 0, so that's going to be 0y. -8 plus +1. Put that 1 there if you need to remind you that there is a +1. It's not 0, it's 1. So 8 minus 1 is 7. We're combining x's, don't forget the variable, and we have more negatives than positives, so this is -7x plus 0. I'm going to just cross through the 0, bring down the equal, and then 9, take away 2, 9 plus -2 is +7. Divide both sides by -7. -7 over -7 is 1x equal a positive divided by a negative is a negative. 7 divided by 7 is 1. So x equals -1. See if I can write that a little more neatly for you. All right, distributing through by a -2 gives me -8x minus 2y equal -2. Make sure you're writing this down on page 116. I'll be checking in your workbook. All right, combine this top equation that we've multiplied through by the factor of -2 to the bottom equation. and we will get negative 7x equal 7. Divide both sides by negative 7, and you'll get x equals negative 1. Now what do we do with that negative 1? We're going to take it and we're going to substitute it back into either of the original equations, not the equations that we changed, but into the originals. So I'm going to use that second equation because it seems simpler. Substitute in negative 1 for x in that bottom equation. So negative 1 plus 2y equals 9. Then add 1 to both sides. Negative 1 plus 1 is 0. Bring down the 2y. Bring down your equal, and 9 plus 1 is 10. Divide both sides by 2. And what is 10 divided by 2? 10 divided by 2 is 5. Okay, so we have our x is negative 1. We're going to put it here in our coordinate pair. And y is 5. We're going to place it in that second place where the y coordinate goes. All right, now consider these two equations again. The same two equations. Now pick a number to multiply the bottom equation by to try to get matching coefficients but opposite signs. All right, so we're going to keep the 4x plus y equals 1. We want to try to match up either the 4 or the 1. So we could multiply through by 1/2, but I'm going to avoid fractions because those tend to give me more stumbling blocks. What would you multiply that bottom equation by to get these x's to match up? If you said negative 4, you would be correct. If you said 4, we just forgot the negative. So let's distribute that negative 4 through. Negative 4 times x is negative 4x. Negative 4 times positive 2 is negative 8. And then negative 4 times positive 9 is negative 36. We have everything lined up, so let's go ahead and add. 4, take away 4 is 0. I won't write that. And then y, take away 8 is negative 7. Y. 1, take away 36 is negative 35. Divide both sides by negative 7. Y equals positive 5. Negative divided by negative is a positive. Take that negative 5 and plug it into either of the original equations. Let's go back to the original equations, equation A and equation B. I chose the top equation. Okay, I'm going to place 5 here for y. 4x plus 5 equals 1. And then I'm going to solve for x. I'll start by subtracting 5 from both sides. 5 minus 5 is 0. Bring down the 4x. Bring down the equal. 1, take away 5. We have the 4x left on the left. And 1 take away 5 is negative 4. The last step is to divide both sides by 4. 4 divided by 4 is 1. 1x equals 4 divided by 4 is 1, but now you have a negative and a positive. That's going to give me a negative number. So x is equal to negative 1. We have our y and we have our x. You can write it this way, or you can write it as a coordinate pair, negative 1, 5. Also, one thing I forgot to mention is we kind of skipped over this on page 116. You could put these equations into Desmos just like they are, and you can find the solution where those two equations intersect. Remember to use that to check, because when I'm going to be grading your work and on your test, you need to be showing your steps. At the top of page 117, to the right of the equations for activity 1, take these notes. So everyone turn to page 117. I'm going to give you 2 minutes to write these notes down. First thing that you need to do is make sure that both equations are in standard form. Standard form has both variables on the left and the constant on the right. Look for common multiples and multiply by a number in one or even both equations to create opposites. Then you're going to have everything lined up and you're going to add straight down to eliminate one variable. This, unlike yesterday, is elimination. Yesterday was substitution. Now solve for the remaining variable and then use that to find the other variable. Copy this problem on page 117 under number 1 and then solve it. On page 117, number 1 says, what were Elena's first two moves? What might be a possible reason? Just mark through that, and we're going to replace that question with this system, and I want you to take a few minutes to solve it. Pause the video. Once you have an answer, a solution for X and for Y, come back and follow my steps. And just remember that my approach is not the only approach that can be used. So your answer and my answer can be correct with different approaches. All right, pause it now and then come back when you're done. All right, what I noticed is that 2 is a multiple of 4, so I can multiply by a factor of 2 in the second equation. But in order to make these opposites, I'm going to have to multiply by negative 2. So take that negative 2 and multiply each term. Negative 2 times positive 5 is negative 10 x. Negative 2 times positive 2y is negative 4. So I'm going to write plus negative 4y. That's what I was, that was my goal. Is what I was trying to accomplish. So I did that successfully. But don't forget to distribute that to the right-hand side of the equation. Negative 2 times negative 4. Two negatives multiply together to give you a positive 8. 2 times 4 is 8. Now I'm just going to copy this equation underneath, keep everything lined up. So that first equation is positive 3x plus a positive 4y equal positive 6. I'm going to draw a straight line and then I'm going to add like terms. So negative 10 plus positive 3, opposite signs you subtract. So I'm going to get 7 and we have more negatives. Look at the absolute value. Absolute value of 10 is greater than the absolute value of 3. Absolute value is just distance. So we take the negatives and then these are going to cancel. Negative 4y, positive 4y, bring down the equal, and 8 plus 6 is 14. Divide both sides by negative 7. Negative 7 over negative 7 is 1x. Bring down the x, bring down the equal. 14 divided by 7 is 2. Positive divided by a negative is a negative. So we have our x. Go back to either equation. I'll go back to the top one. I'll just pick the top. And I'll substitute in negative 2 for x. So this is going to be 3 times x. We found that x was negative 2 plus 4y equals 6. Alright, 3 times negative 2 is negative 6 plus 4y equals 6. Add 6 to both sides. 6 plus negative 6 is 0. I'll just mark through that. I won't write the 0, but I'll bring down the 4y, bring down the equal. 6 plus 6 is 12. Divide both sides by 4. mark through the 4 over 4 because 4 over 4 is 1. 1 is an identity. We don't write that. 1 times y, we just write y. Y equal 12 divided by 4 is 3. So we have our x and our y. If the question asked for what is y, we first solve for x and then we get y. If it asks what the coordinate pair is, you can write it this way. -2, 3. Or if it asked for the coordinate. All right, copy this problem under number 2 on page 117. All right, I will be checking in your workbook 5 points added to your homework or your practice grade for this week if you've copied down the steps for this problem. All right, look at these two. Looking at it quickly, I can see that 2 times 2 is positive 4. So if I multiply 2 to every term in this top equation, I'll have a positive 4 and a negative 4 lining up, and that will eliminate the x's, and I can solve for the y's. So let me go ahead and do that. 2 times 2 is, I'll try to squeeze it in right underneath, positive 4x. 2 times y is 2y equal, and then 2 times 3 is 6. Now let's add. 4, take away 4 is 0. 2y minus 4y is negative 2y equal 6 plus negative 8, opposites subtract. 8 minus 6 is 2, but 8 is bigger than 6, so take that negative. Okay, so I have negative 2y equals negative 2. Divide both sides by negative 2. That's going to cancel. Negative 2 over negative 2 is 1y. 1y is equal to 2 divided by 2 is 1, and negative divided by negative is a positive. So y equals 1. All right, we're not done yet. We just found y, so plug it into either of the original equations. So let's go back to that top equation, and we're going to plug in 1 right here for y. So 2x plus 1 equal 3. Subtract 1 from both sides. 1 minus 1 is 0. Bring down your 2x. Bring down your equal. And 3 minus 1 is 2. Divide both sides by 2. X is equal to, this is going to be 1x equal 2 over 2 is 1. So the solution is x is 1, y is 1. Copy this problem in the box on page 118. Okay. All right, so we have 5x minus 2y equals negative 10, and 3x plus 6y equals negative 66. I'm going to look real carefully, and I can see that I can change 2. We have a negative and a positive, but I want to change that 2 to a 6. I can do that easily by multiplying by 3, but you have to remember to multiply every term by 3. 5 times 3 is 15. X. Negative 2 times positive 3 is negative 6. Y equal negative 10 times positive 3 is negative 30. All right, so remember I changed this equation and I wrote it underneath so I can have everything lined up and add my x terms. My y terms will cancel out. That's going to be 0. 3 plus 15 is 18. X. Don't need to write the 0. Write the equal sign, and then 66 minus 30 is positive 36. Go slowly and carefully. Don't forget your negative signs. Divide by 18, and 18 divided by 18 is 1x equal 2. So now we have our solution for x. Let's plug it back into either equation. So let me erase my work up here. You should have it written down in your book. And choose either equation to plug in x. I'll go ahead and plug it into the first equation. So this will be 5 times 2 minus 2 times y equal negative 10. 5 times 2 is 10. 10 minus 2y equal negative 10. Come on, pen, right. All right, subtract 10 from both sides. 10 take away 10 is 0. Bring down the negative 2y. Bring down the equal. Negative 10 plus negative 10 is negative 20. Divide both sides by negative 2. Negative 2 divided by negative 2 is 1. 1 times y is just y. A negative divided by a negative is a positive. 20 divided by 2 is 10. So x is equal to 2, y is equal to 10. All right, we have a word problem on page 119. I'm going to read it aloud. Listen and get a general idea of what it's about, and then go back to page 119 and highlight. All right, a teacher purchased 20 calculators and 10 measuring tapes for her class and paid $495. Later, she realized that she didn't order enough supplies. She placed another order of 8 of the same calculators and one more of the same measuring tape and paid $178.50. Now, this is your second read, so stop the video and then pick up some highlighters and highlight the question, if there is a question. If not, go back and highlight the important information and cross through anything that's a distractor. I know that I've got 20 calculators and 10 measuring tapes. So I've got 2 different types of variables. You can choose one to be x, one to be y, or you can choose C for calculators and M for measuring tapes. And here's your total. Okay. Also, she realized she didn't have enough supplies. Okay, and she placed another order of 8 calculators and 1 measuring tape. We want to figure out how to put that together to get a new total of $178.50. So we've got 2 different equations. All right, let me try to write it because it's on the next slide. So 20 calculators and means plus 10 measuring tapes for a total of $495. So the next thing she realized that she didn't have enough. So we have another equation. She ordered 8 calculators and 1 measuring tape. So 8 calculators and 1 measuring tape. I'm just going to write an M. 1 times M is M. If you need to write that 1, go ahead and write it. And that new total was $178.50. So we have our system of equations. Let's move to the second part of this. Okay, we just wrote this system of equations, and this 178.50 should be up here. I don't know why it moved down. Go ahead and copy that in. I think it's page 1. What page is that? Page 119. All right, we're going to change that bottom equation. Now, it looks like to me if I multiply by -10 each of those three terms, I'll get -80x, -10y, and -1785. All right, go ahead and combine those terms, and we'll get -60x equal, this is going to be 0, this is going to equal to, I don't have that number there, let me write that in. $495 minus 1785 is 1,290. Now we're going to be dividing both sides by -60 to solve for x. There's the 1,290. I wrote it as a ratio. All right, divide by 60. X is equal to $21 or 21.50. Take that x and plug it into either equation. Now I'm going to put it into, we're going back to the original, not the ones that we changed. So I'm going to go to the simplest one for me. You can use either one, but I'm using that second equation. 8 times 2150 plus y, 1y, is equal to 178.50. All right. So 8 times 2150 is 172. Use your calculator, use Desmos, and check my work, because I'm not checking as I'm doing this. If you find any mistakes, let me know. Plus 1y equals 178.50. We're going to subtract 172 from both sides. We're going to get 1y equals 6.50. Now that you have your y, plug it back into either equation. Oh, we don't have to plug it back in. I'm sorry. We just did that. We have our x and we have our y. So x is calculators. You might have used C for calculators. That's fine. So x is 2150 and measuring tapes is 650. Now go into Desmos and graph both of these equations. 20x plus 10y equals 495, and then see where they intersect to check your work. They should intersect at 21.50 and 6.50. Okay, you have practice problems to do, page 123, 1A and B, and number 8. I'm going to move into the next lesson and then give you practice after that. All right, we're still in Unit 3, Coordinate Geometry and Systems of Linear Equations and Inequalities. We're moving into Lesson 12, Systems and Their Solutions. So we're just going to be building on what we already know. All right, of the three equations below, one has one solution, one has no solutions, and one has infinitely many solutions. Match each equation with the number of solutions it has. So this is a review. Think about what we've done before. To simplify the left-hand side, we distribute the 12 into both terms in that binomial. So 12 times x is 12x, 12 times -3 is -36, and we still have plus 18. On the right-hand side, distribute the 6 into both terms in that binomial. 6 times 2 is 12x, and 6 times -3 is -18. Subtract 12x from both sides. That x is not written there. Let me write it. Sometimes my notes are missing some things. Let's see. 12x. Subtract 12x from both sides. That's going to be 0. And then we have 36 plus 18 is a -18. And then we have -18. So we ended up with 12x minus 18 on the left, 12x minus 18 on the right. If we subtract the 12x or we add the 18, we're going to end up with 0 equals 0. But it's a true statement, okay? So I would say that that has infinitely many solutions. The solutions are infinite. Both of those equations, or that equation, is going to give you infinite number of solutions. On the second one, look at the second one, we've got 12x, negative 36 plus 18 added together to give you negative 18. On the right hand side we have 12x minus 12. Alright, let's subtract 12x from the right hand side. So we've got to subtract it from the left hand side as well. Okay, I'm trying to move that over to the left, and I can cross it out on the right. That's going to be 0 x's, bring down the negative 12, bring down the equal, but it also crosses out over here. So all I have left on the left hand side is negative 18. Now let's look at that statement. That statement is never going to be true, no matter how I try to move things around. That's going to mean that there are no solutions. So this is going to be B. This is going to be C. Let's see if this last one has one solution. Alright, same steps. Combine negative 36 plus 18 to get negative 18. Bring down the 12x. On the right hand side we have 8x. Okay, so I'm going to add 18 to both sides. There's something missing here. 4 times 2 is 8, 4 times 3 is negative 12. That's missing. Alright, so let me start by subtracting 8x from both sides. Subtract 8x. 8 from 12 is 4x. We still have the minus 18. Subtracting 8x from the right hand side, which is what I was trying to do. I was trying to move that 8x from the right to the left. That's going to be 0. Write your equal and bring down your negative 12. Now I want to get the constants on the right, so add 18 to both sides. Plus 18. Negative 18 and positive 18 is 0. Bring down the 4x. Bring down your equal. Negative 12 plus positive 18 is positive 6. Divide both sides by 4. And you get 1x. 4 over 4 is 1. 1x is equal to, we can simplify this by dividing both sides by, I'm sorry, not sides, the numerator and denominator by 2. 6 divided by 2 is 3. 4 divided by 2 is 2. So this is one solution when you have a variable equal to a number. So this is going to be A, one solution. So if you try to solve an equation and you get a statement that is not true and never will be true, that's no solutions. If you get a statement that is true and always will be true, no matter how you manipulate it, that's infinitely many solutions. Alright, you know how to do these warm-ups. Take a look and tell me which one, in your opinion, doesn't belong. These can all be justified. I'm looking at the first one. The first one intersects, there's an intersection or a solution on the y-axis. This one only has one line, which means that it's probably two lines that lay on top of each other. That would be infinitely many solutions. One solution here, one solution here, no solutions here. None. So you can justify all of these for different reasons. Alright, activity number 1. What's the deal? This is on page 129. I'm just going to turn in my book to make sure that we have the right page. Please turn in your book to page 129 and follow along. Write down anything I ask you to write down so I can check what you've done in your book when I get back. All right, we have a recreation center offering special prices on its pool passes and gym memberships for the summer. On the first day of the offering, a family paid $96 for 4 pool passes. I'm going to go ahead and highlight just to go through this quickly, and 2 gym memberships. Later that day, an individual bought a pool pass for herself and a pool pass for a friend and 1 gym membership, and she paid a total of $72. So let's write that system of equations that represent the relationship between the pool passes, gym memberships, and the cost. Be sure to state what each variable represents. So I chose P for the price of the pool pass, and I chose G for the price of the gym membership. You can choose X and Y, that's totally fine, but make sure that you write down what those variables are that you chose. All right, so the first sentence says 96 is the total. I'm going to write the total on the right, separate the right and the left with an equal. So what did she buy? Or what did the family buy? 4 pool passes, so 4 times P, and 2 gym memberships, 2G. That's the first equation. The second equation, an individual bought a pool pass for herself and a pool pass for her friend, so that was 2 pool passes, 2 times P, and 1 gym membership, and that was a total of $72. So now we have our system written down. Copy that down in your workbook, and then find the price of a pool pass and the price of a gym membership by solving this system. You're going to do it algebraically, and then explain by showing your work, or explain in words, explain your reasoning. All right, this system has no solutions. So what I did is I multiplied that second equation by -2. Okay, when I multiplied that second equation by -2, you can see that you get -4P, -2G equal, and let's go ahead and multiply that -2 times 72, and you get -144. Okay, now if you combine these, 4 take away 4 is 0, 0P, and then 2 take away 2G is 0G. We just have 0 on the left, and we have 96 take away 144. Let me get my calculator. 96 take away 144 is -48. So that statement is not true, and it never will be true. There's nothing we can do to make it true, so that has no solutions. Now use graphing technology. So put these systems, both systems, I'm going to erase so you can see what they are. It's also in your book. Okay, and then make 1 or 2 observations about your graph. So take a minute to do that, and then compare it to this graph that I have here. All right, we have one line that's going to intercept the y-axis a little below 50, another that's going to intercept the y-axis right around 70, but you can see that those lines are parallel. So there are going to be no solutions when lines are parallel. All right, lesson debrief. Turn in your book to the debrief, read through, write down any questions you have, go over these examples. Okay, look at the number of solutions when lines intersect. If you can use your calculator, you can see that there's 1 solution. And then solving it algebraically, what we've been learning with substitution and elimination, we can find the solution and we can verify it with our calculator. All right, if we have one line with 2 equations, we're going to have an infinite number of solutions. We'll end up with something like this. And you'll see that there are not, when you put those 2 equations in, there's only one line. So that means that these are both the same line. They just lay on top of each other. And then when lines are parallel, we're going to have no solution. You can see that with the calculator, and then algebraically you can see that we've got a statement that will never be true. Activity 2, sorting systems. The tell is these systems will have, or we need to tell if these systems will have one, none, or infinitely many solutions. So we're going to solve that first system. Okay, if you solve it, let me see how I would do that. I'm just going to, because I have y equal and y equal, I'm going to substitute this in for y and write it as 2x minus 7 is equal to negative 7x plus 2. Add 7 to both sides, 7x. It's going to cancel out on the right. On the left we have 9x. We still have the minus 7, so I'm going to add 7 to both sides. Okay, 7 plus 2 is 9. And then divide both sides by 9, and you get x is equal to 1. Okay, you can plug that in to either equation and find your y, but we're going to have one solution there. For this one, again, I can substitute this in for y and get 2x minus 3 equal 2x minus 13. Okay, when I subtract 2x from both sides, I just get, it's going to cancel on both sides, and I get negative 3 equals negative 13, and that's never going to be true. So there are no solutions. And the last one, if I multiply this top equation by 3, I'll get the same equation here. That's infinitely many solutions. All right, same thing here. We can solve, we can look at those and see if we have one solution. No solutions means we're going to have a statement on the left that's never going to be true. It's never going to match what's on the right. All right, just quickly, we're going to look at substitution one more time. If you have a variable isolated, I have y equals negative 2. I can replace the y in that second equation with negative 2. So you have negative 3 times negative 2 is going to give me a positive 6. So 4x plus 6 is equal to 18. Subtract 6 from both sides. Draw your line. Bring down 4x. Bring down equal. 18 minus 6 is 12. Divide both sides by 4. X is equal to 3. And we already have y up here. Y is equal to negative 2. So all we had to do was find x. So our solution is 3, negative 2. All right, now let's look at this set. I have y equal, now it's not just a number, it's a binomial. So I'm going to substitute this 6x minus 11 in for y. So negative 2x plus, let me change that to plus and negative. It's a negative 3. Negative 3 times 6x minus 11 equal negative 7. Negative 2x, let's simplify. Let's distribute that negative 3 to the positive 6 and to the negative 11. So negative 3 times positive 6 is negative 18x. Negative 3 times negative 11 is positive 33 equal, we have that negative 7 on the right. So let's combine like terms. We have an x, negative 2x Negative 18x is negative 20x. Negative 20x plus 33 equal negative 7. Now let's move the constants to the right. Subtract 33 from both sides. Alright, bring down the negative 20x. 33 take away 33 is 0. Bring down the equal. Negative 7 plus negative 33 is negative 40. One last step, divide by negative 20 on both sides. Negative 20 divided by negative 20 is 1x equal, a negative divided by a negative is a positive, 40 divided by 20 is 2. So x is equal to 2. Plug x back into either equation, put it here. 6 times 2 is 12, 12 minus 11 is 1, so y is equal to 1. Alright, substitution. So for practice, complete pages 134 through 136, questions 1 through 6 in your workbook. Then transfer your answers into Canvas.